One second. Already live. I'm already alive. I'm just going live. Yeah, it's showing live, but it's not loading. It's showing an error. Yeah, I'm already live. Good evening. Good evening. So just give me one second. Okay, guys, then so we can start the class then. Good evening, Gopika, and everyone else. I don't know it. And good evening, all the people who are in. But okay, so we'll glance one more time, then we can move to the uh, next things. Okay. So first thing is what we studied in the last class. The first thing we studied in the last class is the what are the biomolecules, right? Then we studied about the methods of separating the biomicromolecules and biomacromolecule. Huh, Sushma, I got to know. That's why off the video. Okay. So if it is continuous, please inform me. Okay. So I will check with the internet. So for separation of the biomass, we ground the plant or animal tissue with what? With Cl3, Cl3, C, COOH. That means what? That means trichloroacetic acid. Right, we can call it as a TCA. So then we got two things. What is that? One thing is the filtrate, right? And another one thing is the retinate, retinate. Okay. So what is the filtrate? Filtrate means the liquid, what is available in the left or what is come off the cheesecloth. Okay. I'll write like some cheesecloth here. Okay. Cheesecloth. After the filtering with the cheesecloth, we got two separations. One is the filtrate, the liquid state. So we told that it contains the micromolecules because these are small and some things are left in the cheesecloth. We call it as the macromolecules, what is retained, or you can call it as pellets. Pellets are available. We call it as a retinate. Okay, try to remember the words. Filtrate, opposite is the retinate. Right. Then we did what? So after taking this, we started to doing the analysis by the different procedures based on the different chemical procedures. Okay, different chemical procedures. So we retinate. Yeah. So we started to do. I think T only. Just check guys. TE or TA. Just check that one. Okay. Yeah. Uh, yeah, retentate. Exactly. Retentate. Okay, retentate. So we just use the different chemical procedures to analyze it is a functional group or does it have the aromatic ring or does it have any how many carbon atoms and everything. Okay. Based on that, we separate into different kinds of the compounds. The major things are the carbohydrate. It may be a carbohydrate or it may be a lipid or it may be a protein or it may be a nucleic acid, right? Nucleic acid. I'm simply write it as nucleic acid. Then we will study anyway. No. Uh, Analysis. And I didn't understand, Chirant, what you were saying. What are a filter analysis? How the analysis are going on? You are asking. So how we know that ethanol is having that particular structure only, or how we got to know that benzene have that particular structure only? Probably you guys, when you started to doing the organic chemistry, you will started to learn all those things. Okay, we know that certain functional groups will react with some other and give that particular product, right? So we will do that kind of series of reactions. Based on the results of those reaction, we will speculate a particular kind of a shape. Okay, a particular kind of the shape or the bonds, everything. right? So if it's like three carbon compound, and you are making reaction with this one alcohol, and alcohol is come and joining to any one of the carbon, right? If there is a space and everything. I forgot some of the chemistry, okay? So don't mind me if I saying something wrong. But uh, Buccal biomolecules. Huh, yeah. Biomolecules means, remember, it may contain organic and inorganic molecules. Okay, so complete molecules. But what we are studying, those, sorry, molecules, but inorganic molecules in biomolecules only refers to the ions. Okay, normally refers to the ions. So we will normally left it in this particular chapter. We will study later on. Okay, so the major biomolecules what we study is these four only. Only nucleic acid, protein, lipid, and the carbohydrate. Okay, good evening, Darshan. Good evening, Akil, Ashwin. Okay, and later in that we started to study the carbohydrate. What are carbohydrates? These are the polyhydroxy ketones or aldehydes, and these have kind of different kinds of structures, right? The majorly these structures are based on the carbon atom. We divide it into triose, tetrose, or pentose, or hexose, and heptose, right? And these are based on how many carbon are there, right? How many carbon in single unit, how many carbon in single unit, based on that. But sometimes what happens, these single units join to form some other structures, right? If I write something like this is a single unit of the carbon, think that it's a glucose, okay? But sometimes what happens, a condensation reaction will go on. Due to the at the end of the condensation reaction, this will be form a combined form, right? So what happened here, here is one, here is the one saccharide, here is the another unit of the saccharide. They combine to form, we call it as disaccharide, right? So this kind of bond may happen. This bond actually happening in between these molecules are called as the glycosidic bond. Glycosidic bond. So this glycosidic bond normally work in this way, COC or CNC, normally this one, okay? This glycosidic is form of a ether bond that you will learn in the chemistry, okay? Mm, bond yes, remember whatever the things we study about the carbohydrate, the bond happen in between the carbohydrates, or bonding happen between a monosaccharide to another monosaccharide, a monosaccharide to another oligosaccharide, or sugar is joining to a polysaccharide. Everything is glycosidic bond only, okay? It's everything is the glycosidic bond only, okay? So a kind of a bond, a kind of ether bond, okay? That's what we studied in the last class, and we also studying about some other things, right? So I want to add one more things to this particular one. Yesterday I didn't mention, okay? Yesterday we studied about two things, right? One is the monosaccharides, and another one is the oligosaccharide. If you go for its structures or its properties, okay, both of this have the almost similar properties. That means most of the monosaccharides are reducing, right? Reducing means what? It can have the ability to reduce Cu2 plus ions of the Cu2 plus ions of the this one reagent from the Cu plus state, right? And most of them are sweet. Okay, they are sweet. You can take example of glucose, or you can take example of sucrose, maltose. Okay, so most of them are sweet. Okay, and when you make it like a concentration, they form a crystals. Okay, they are crystalline. So you can remember this by watching your sugar. If you ever, probably everyone saw sugar, right? So sugar or glucose is normally available in the form of crystals, not in amorphous state, right? It will be available in the crystalline shape. Okay, that's the important thing. Exactly. In this exception is the sucrose. So sucrose is non-reducing. Why it is happening in that way? Because the bonds, the aldehydes and ketones are normally bonding with the things. That's why bonding, sorry, aldehydes and ketones are forming the bond. That's why it's non-reducing. Okay. Benedict reagent or Felling reagent, both of them are correct. Okay. uh, and another kind of covalent bond, no, like remember, these are names of the bonds. Okay, these are what we are studying about the covalent bond or ionic bond or whatever force, everything will state about the bond between each element, right? If there is a C and O bond is happening, we normally state is it a, it's a covalent bond, or it will be a partial ionic bond, right? But here what we are stating, what kind of bond it is. Okay, that means in between which element is happening or in which angle it's happening. Based on that, we will give a name. Okay, this is not related to covalent ionic, that kinds of bond. These may be a covalent bond only. Okay, but it's made up of the more than one element, and it's the name of the configuration of the bonds. Okay, those two things are not same. Just remember that. Okay. We discussed about these things. Please do remember, monosaccharide and oligosaccharides normally reducing, and they will be sweet in taste and they will be crystalline, right? So these are the characters related to that. And most sweetest, most sweetest, most sweetest is the fructose. Okay, so where it's available, fructose is available in the fruits, right? So what happens? That's why fruits are so tasty, because fructose will be available, and fructose will be most sweetening agent. Okay, it have a higher sweetening levels than the sucrose. Okay, and this one is the what is that? Our lactose is the less sweetening. Okay, that's why the milk without sugar normally won't feel that much of sweet because of this reason. Okay, galactose is the monosaccharide, right? It should feel sweet, but I'm not sure. Okay, and another one thing I thought of adding to this, don't think that the carbohydrates are the only thing which give the sweet. Carbohydrate are the basic things, or what we know until recently. So which are the sweetening agents? Okay, now there are several compounds are there, some protein and some other chemical compounds are there which will be having more sweet than the sugar. Okay, that's secondary. Both monosaccharide and oligosaccharide form the crystalline structure. Exactly. Molecular molecules have to start. Okay, okay. In some kind of pills, very sweet. What about its composition? Remember, whenever a particular leaf, a plant leaf or something is sweeter in taste, okay, not the fruit part, it's most probably due to the presence of the sucrose, not the fructose. Okay, fructose normally formed in the fruits only. The sucrose will be formed. The sucrose will be deposited, or glucose will be deposited in the other fruit parts. If you take example of the nectar is normally filled with a glucose. Okay, why it's glucose? Because it's readily available in the plant. No need to make any changes or anything, right? That's why. So it's a readily available form. That's why those everything is related to the other kinds of the sweetenings. That also depends. Okay, different kinds of sugars will be there, different levels. Honey is the more complex one. It's having the different composition of the sugars. Okay, fructose also monosaccharide. Exactly. Glucose, fructose, everything is monosaccharide only. Okay, galactose, everything. Okay, shall we move on then? Okay, question came. Do sugarcane have fructose? Sugarcane have the sucrose, not fructose. Okay, that sucrose again have the fructose. Okay. Uh, Hydrogen and oxygen present typically in the proportion of water in. Okay, they are asking hydrogen and oxygen where it is present typically in proportion of the water. Okay, is it in protein, or is it in carbohydrate, or is it in lipid, or is it in the nucleic acid? Think a little bit, then answer. Okay, so do sugarcane? It's also contain enzyme of B. A lot of things will be there. Honey is a complex liquid. Lactose, lactose means lactose is a disaccharide. We discussed this, right? Okay, I'm just launching the poll then. So try to answer in the poll. Before you answer, just think about it one more time. Okay, whatever may be your answer, think about it one more time. Okay, I'm getting the answer. I'm just checking the poll. Okay, so many people are giving correct answers. Some are still confused. No issue. You guys still have the 20 seconds of time. You can utilize this time to answer. No problem. You have to think about one or two things. Then you can get the answer. Right. Okay. Okay, I'm ending the poll then, guys. Uh, I'll come back to that, Jeevan. 1 second. Okay. I'm sharing the result. 16% chosen option A, 63% chosen option B, 4% C, and 16% D. Okay. I'm stop sharing the result. Most of you people think that answer B is correct, even in the YouTube also. Okay. We'll see what will happen. Uh, yeah. So protein is normally made up of the things which is having a NH2 also, and also a COOH group, and also R group, and also a H, and everything. You can see that it's not that much representing the water kind of the things, right? And lipid is more of like the alcohol related alcohol joined with the some of the glycerol molecule. Okay, it's also more complex things. Nucleic acid is completely different. It will be having phosphates and all the things. Okay, nitrogen and all the things. The carbohydrate, if you look here, it will be having what's the general formula? CnH2nOn, right? In a simplification, I can also write it in this way: CnH2O and N, right? So this carbohydrate is mostly expressing, or the general formula will mostly represent typical of a water, right? That's why the answer B is correct. Okay, so you can modify these general statements so you can answer it properly. Okay, what is the meaning of the question? Meaning of the question is hydrogen and oxygen are present typically in the proportion of the water. They are asking in where or in which kind of the molecule the hydrogen and oxygen compositions are typically related to water. That means if you check here H2O, right, proportions are there. The proportion of hydrogen and proportion of oxygen is almost similar to the this one, right, water. That's what they're asking. Exactly. That's only for simple sugar. No problem in that. But these multiple choice question, when you are choosing, that's what saying. They won't. Yeah. Now it's okay, I think. Okay. They never ask you which is 100% correct without any exception. They will ask you in the four option which one is correct. Okay, in the four option which one is correct. In higher carbohydrates, the proportion may become little bit different. Okay, what's the reason for that? The reason is because one water molecule is removed. Even though one water molecule is removed, what happens? N minus 1 will happen, right? H2O, N minus 1 will happen. That means one molecule will be removed. So still it's almost represent the water only. Yeah. And something, like someone is asking, like, when we go to the doctor will say that if you are thin, they will say we have to take honey, and if you are fat, they will say you have to take honey. How it will be different? Okay, how it will be useful? One thing for sure is honey is very good to our body. The yes, exactly, honey only. Exactly. Doctor will say same thing. Okay, not a regular doctor, Ayurvedic or naturopathy doctors will say that. Okay, so and they will give the different composition. Probably they will give for the thin people. Probably they will say just mix it with the cold water and drink. For the fat people have the obesity, probably they will say mix it with the hot water or something. Okay, I'm not sure about those things. But the thing is, the honey contain very good number of the minerals and very good number of the this ones. sugar molecules, and not diabetes patients also can take honey, because it not increase the body sugar level all of a sudden. It will take lot of time for the honey to give all its sugar composition. Okay, probably that may be the reason. And we are not sure about some things behind the Ayurvedic medicines. Okay, we know it will work, we don't know how it will work. That's the major problem whenever discussing with some allopathic scientist. Okay, they will ask you to take honey in hot water. Huh, yeah, yeah, exactly. So they may ask you like, you guys say something like that, but you don't know how it works. But allopathic medicines, we know how it works. I will give you a certain medicines. It have that particular chemical. If you take like any allergic medicine, I will take something. It will inhibit the regular neurotransmitter. So what happens? Your symptoms will be reduced. Allergic symptoms will be reduced. I know that. But how can you explain that if you have allergy, you guys will say that apply the turmeric, okay? But which compound in the turmeric will work? We don't know that. That's what making Ayurvedic a little bit slow in the race. Okay, that not because Ayurvedic is not working. Ayurvedic is working, but the issue is like it will be slow because very less work is going on, and very less work is already done regarding the how it will work on the that particular patients or the body of the humans. Okay, we know it works, we don't know how it works. Okay, that's the only thing left. Is flowers contain sugar content? Exactly, flowers will have the nectars. The honeybee will connect the nectars, or it will eat the nectars, and it will partially digest it, and in its digestive system it will convert into some other kind of the complex sugar. We'll move on to the second question. Reducing sugars are glucose, fructose, galactose, maltose, lactose, glucose, sucrose, cellulose, lactose, starch, glycogen, none of the above. Okay, this is none of the above. Okay, I'm just launching the poll, guys. You can, you can say like that. It's not poop. Actually, it's vomit. You can say. Okay, I'm relaunching the poll. Honeybee will eat the nectar, and it's partially digest it, and it will throw it up. Okay, it's kind of like vomiting. Okay, so it will go through that kind of process several times, and the water content will be reduced. So nectar will be having high water content. So after like reduced water content and increased sugar content, later it will be deposited, because if water is there, bacterial growth will be there, right? If there is no water, high concentration, high salt concentration, then bacterial growth will not be there. That's why it's a storing material, right? Huh, Akshay, that's the thing. Like a lot of research have to be go on Ayurvedics. Okay, if you guys have a time, like if you have any mind of going to the research field, you can take up anything like that. We have a lot of kashayas, right? So we don't know how it will work, but it works, right? So some things placebo will be there. I'm not telling everything is exactly correct, but most of the things are working because thousands of years people are practicing, right? Yes, I'm just sending the pool. Okay. I'm just sharing the results. 54% chosen option A, 13% B, 24% C, and 10% D. Exactly. Reducing sugar means it should be a monosaccharide or it should be a oligosaccharide. So if you check here, none of the above, we don't know that. Lactose, starch, and glycogen. Lactose, okay, but starch and glycogen are polysaccharide. That means a larger kind of the saccharides. Yesterday we didn't study about these things, right? So you can remove this one. Glucose, sucrose, and cellulose. We know sucrose is the non-reducing, so you can remove this one. And glucose, yes, it's a monosaccharide, and fructose monosaccharide, galactose monosaccharide, maltose are disaccharide, and lactose is a disaccharide. So all of them are reducing sugars. So the correct answer is the option A. The correct answer is option A. Okay. And YouTube also everyone given the correct answer. Pawan is asking, is honey won't get damaged for many years? Exactly. Regular honey, if it's a good honey, like when you see a honey, you can differentiate the things. Okay, so how much purified it is, how much good it is. When you collect it from the wild, if, probably some, at least some of you know how to collect the honey from the wild and everything, right? So those honey are very good kind of the honey, will not be get spoiled if you kept it in a like airtight bottle for many years. Okay, so the old honeys have the higher values because people believe that if honey get old, it will have the higher medicinal property. Okay, so that's why. What's the meaning of the reducing sugar? Reducing sugar means simple glass bottles. Huh? Reducing sugar means the sugar which can reduce Cu2 plus ions to Cu plus state. This Cu plus ions will be present in the reagent. Okay, reagent. Okay, simple. It's reducing from here to here. What's the reason for that? Because of the open aldehyde and ketose groups, which will react with this Cu2 plus ion, and because of that, it will get reduced. Okay, 10 box opening is for the awesome, awesome, dude. For me, one bottle then, Preetham. Okay, we'll move on. Okay, today we are going to study about the amino acid. Remember, any micro alcohol, ha, like composition matters, Pawan. Like you're asking about the alcohol, right? Like how much percentage also matters for like microorganism to survive. That's why normal will contain up to the 65 or 69 or 70% to the 93%. Okay, 100% ethanol can survive. 100% ethanol, it can survive. It should be less than 100% for microorganism to die. Okay. So I normally write amino acid in this way. Okay. Just remember. Oligosaccharide is done. Yesterday only we completed, right? Oligosaccharide, only disaccharide is important. Nothing else we are studying. Nothing else we don't, no need. Okay. Polysaccharide, we will study it in the macromolecules. Polysaccharide, we will study it in the macromolecules. Now we are studying about micromolecules only. Mm, no, fructose is also reducing sugar only. Sucrose will give rise to glucose and fructose. But in glucose, sucrose, what happened? Glucose and fructose, both of their aldehyde and ketose groups are involved in the bond formation. That's why it's a non-reducing. Okay, glucose is reducing, fructose is reducing, but the sucrose is not reducing. Third division of carbohydrate is not completed. Third division is polysaccharide that included under the biomacromolecules. We will study it in the macro. Now we are only studying the micromolecules. Okay. Now monosaccharide and oligosaccharides are micro. Amino acids are micro. And these are the micromolecules. We will complete this. Then we can go to the other section. Okay. Next section. So what are amino acids then? Amino acids are the very important thing in our body. Okay, because amino acid will give rise to the proteins, which are the building blocks of our body. You already seen, right? 13%, sorry, 16% of our body is composed of the this only, right? Our proteins only. Okay, so what are these amino acids? Amino acids are organic acids, especially carboxylic group. Okay, with carboxylic group, I will write like this, COOH. Okay, having a amine group, having a amino group. Okay, what is amino group? Amino group is NH2. Okay, amino group is NH2. Generally, what happens? These are the monomer of protein. Exactly, Lipika. These are the monomer of protein. What's the meaning of monomer then? Probably you studied this one, right? Polymers and everything, at least a little bit. A monomer means a single unit of thing. When it is segregated, it will form a polymer, a large structures. Okay, so when you start to add the amino acid one to another, then it will form a long chain and it will form a protein. Okay, Exactly. These are building blocks of the protein is a building blocks of our body, and the amino acid is building block of the protein. You can say that, no problem in that. Okay. So when you check about its structure, okay, its structure, it will be something like that. Carbon will be here, and one side it will be having NH2 group, and another one side it will have the COOH, and another side it will have a variable group we represented in the form of R, okay, and another one will be the H, okay. Substituted methane, sir. No, we can't say it's a substituted methane because methane group is not mandatory here. Okay, methane group may be present, but it's not. It's in text. Substituted methane. How it happened? It should be methane means C. Okay. Substituted methane means in. Oh, okay. I understand now. Okay. So I'm a little slow in chemistry. So they removed H. H will be removed, and a new functional group is added. Right. So R means variable group. Variable group. Probably you use these things in chemistry, right? It may be anything. Sometime it will be H, or maybe CH3, or maybe COH. Something. All the different things. Okay. No issue. No problem. Okay, order may be a little bit different. No problem. Okay, I can write it like this or write it like this. No issue. Nothing will happen. Okay, so both will be okay. Both will be accepted. Okay, so remember here what happened. A single carbon atom is here, and it is attached with the one hydrogen atom, one variable group, and one NH2 and one COH. This variable group may be different. It may be a H, or it may be a CH3, or CH3 means one H will be removed, right? That's why I mentioned, or something else also. Okay, etc. I will write it is. Okay. So, what do you guys tell about this particular carbon atom then? A carbon atom is there. It's actually attached with the four different group of atoms. What do you call this carbon atom? Do you guys know? What is the name of this carbon atom? No, not alpha. I'll come to the alpha one second. Okay, not alpha. A carbon atom which is attached by four different atoms or group of atoms. I will tell you, this particular carbon is called chiral carbon, or you also call it as chiral carbon. Okay, chiral or chiral carbon. What is the meaning of this? Chiral or chiral means carbon, carbon attached with four different atoms or group of atoms or group of atoms. That means what? If you find any carbon which is attached with the four different atoms, like one may be hydrogen, one may be some other atoms, or four group of atoms, then that particular carbon is called chiral carbon or chiral carbon. Okay, the pronunciation is different. Which one do you like? You can use that one. Okay. So, that's one thing. Second thing, if you observe in this particular structure, this particular carbon is attached with the functional group. If functional group is directly attached to that single carbon atom, then we call that kind of the carbon as the alpha carbon. Okay, we call it as the alpha carbon. Alpha carbon. Why we call it as the alpha carbon? Alpha. Okay, because it is attached with the functional group. Functional groups are attached to that particular atom. Okay. Why I am mentioning only the alpha carbon? It's all the four are hydrogen. If all the four is second degree, okay. If there is two things are like same, two functional groups or two atoms are same, then it's non-chiral or non-chiral. Okay, so when you start the this one, what is that, your organic, you will start to know about all these things. Okay, how the structures and how spatially it will be arranged, why we have to call it chiral, and what is properties, everything we will study there. Okay. H function. No, H functional group. H atoms, hydrogen atom is attached there, and others are there. We will say in that manner. Yeah, four different atoms we have to write, but spatial arrangement also we have to see, right, before writing the four different atoms. That's also there. Alpha carbon. Okay, the carbon which is attached by the functional groups, which is called as the alpha carbon. If I have to say a carbon as the alpha carbon, that carbon should be attached with the functional groups, okay, or the actual or main function group, okay. Why we are studying about the alpha carbon then? Is there any other kind of the carbons will be there? Yes, there are several kinds of the carbon will be there. I will come to that. Or someone asked the question. Lipika, I will come to that once again. Okay. Sir, can R be replaced by all the functional group? R can be replaced by anything. We will come to that next examples. Okay. Um, ha, ha, ha. Minimum one functional. Minimum one functional group. Okay, no problem. Okay. Ha. So there are like different function. Here also C is attached to functional group. Yeah, exactly. Here is also C is attached to the functional groups only. Okay. Uh, yeah. So what happens? There are like when it's a long chain, there are several carbons. Okay, where the functional groups will be attached. Okay, then we will get confused, right? So there will be like alpha carbon will be there, beta carbon will be there, gamma carbon will be there. Like it will be continued. Okay, but remember, alpha carbon is the only thing we are studying here because the protein will contain only the alpha carbon containing amino acids. That's why I can replace this word as the alpha amino acids. Why? Because protein only contain alpha amino acids and nothing other than that. Okay, only the alpha amino acids will form the this particular kind of the proteins. Okay, involved in the protein structures. Okay, not the any other kinds of the amino acids. Okay, not beta, gamma, nothing. Okay, so all only alpha amino. CRH. I'm not sure about that. You have to ask the Shiva sir about CRH or something other reaction. Okay, so this is a basic one. We will see next, like what happens. What is it? CRDH? I didn't understand. Okay, so what happens here in this particular structure? It have the both carboxylic and amine group, right? The carboxylic group, as you already know that it's the acidic group, right? And amine group is the basic group. So when it will lose, the NH2 will lose one electron and it will show the positive and it show as the cation. Okay, cation at the low pH it acts as a cation, that particular amino acid one part. Okay, but at the high pH what happens? This will retain, but COH will lose, sorry, accept and form a anion. Okay, so sometimes what happens? A single amino acid may have both positive and negative ionic states. Then we call that kind of ions as the jitter ions. Jitter ions means the amino acid which have both cation and anionic state. Cation and anionic state. Anionic state. Okay, so what's happening here? In low pH, it's actually gaining the electron, not gaining. It's losing, right? It's losing the electron and it's forming the cation. And in the high pH, it's accepting the electrons and it is forming the anions. Okay, but in sometimes it will be form a in between shape. That means will having the both positive and negative ionic states. That means both cationic and ionic phase. We call it as the zwitter ions. Okay, this is one of the important property of the amino acid which helped in the formation of the bond. Okay, we will move on. Yeah, this is a simple thing. Okay, we will move on to the types of the amino acid. Okay, so there are like several types are there. Remember, these are not all of these are important. I will tell you which of the amino acids are important. Before that, before we going for the types of amino acid, I just want to mention two things. Okay, I'm taking the another one slide here. I will add it to the later on. Okay, so give me 1 second. Screen, black screen. Okay, so there are, as we know, 20 amino acids are there. Okay, 20. 1 second, where YouTube went? 20 amino acid are there. PK, HPK, HPKA, PKA, PKB, everything is, don't ask me now. Okay, it's a long process, how it will be the variation, everything. So Shiva sir will tell all about this. Okay, acid and basics, that reactions. Okay, so there are 20 amino acids are there. Okay, 20 known amino acids are there. So you guys can ask me, is there any more amino acids are present? Yes, but these 20 amino acids are important because only these are protein forming. Okay, these are only protein forming amino acids. There do present another amino acids. That means there are like another hundreds of amino acids are there, but those are not important because they will not never form the amino acids. Okay, they will never form the proteins. Okay, that's why those are not important. When we are checking the structure, someone asked about, so this is a general structure, right? This is the general structure, NH2 and COOH. And what happens, it will, if I add H in here, okay, remember this is glycine, this is the simplest amino acid. Remember, there will be no other simplest amino acid apart, other than glycine. Okay, this is the simplest amino acid, and this is the a non-chiral amino acid. Okay, a non-chiral. It's an exception. You know, chemistry loves exceptions, right? So it's the non-chiral amino acid. Remember about this. Okay, so in last year probably, in CBSE they asked the question to write the structure of the glycine. Okay, the structure of the glycine. Why they asked that? Because it's the simplest one. Okay, so exactly. And later we will come to this. So what happens if I replace that particular H with a amine group? Okay, what happens if I add a amine group here? Okay, this is called as the alanine. Okay, alanine. Okay, remember variable group, how it is changing, right? How non-chiral? Because it having the two groups, right? We told all them groups or atoms should be different, but H and H are similar, right? That's why. That's why. In chemistry, you will see geometrically how it will not be chiral and how chiral. Okay. So I will take another one example here. Okay. So if I take another example like C, C and H, NH2, everything is similar in here only. Okay, and but here it will be different. It will be something like okay, H2COH. Then it will be serine. Okay, the name will be serine. Okay, so remember, that's why I told this last one is the, once again, HCNH2 COOH, and this last one as the variable group or R. Why it's variable group? The change in the variable group will give rise to different kinds of the amino acid, and the change in the variable gives rise to different properties to the amino acid. Okay. If I take an example, alanine is a non-polar. Okay, alanine is a non-polar amino acid. But if you come to the some other, like if you come to the serine, this will be the polar amino acid. Okay, remember the upper structures are same in both the ways, right? But the functional group or variable group is changing. Sorry, not functional. The variable group is changing the property of the amino acids. Okay. Mm, if it not um, hinders its spatial geometrical issues, then you can write. Okay, so Lipika. So what happens when you are writing this NH2 and COH, right? Why we normally write it like this? Because like spatial arrangement and everything, you can also write it like NH2 and COH also. Okay. So other way also, no problem. But it's just an example. That's why we are writing like in this way. But in formation, we will write. It will be something different also. Okay, so remember the variable group will give rise the properties of that particular amino acids. Okay, only variable group. Other things will be, it may control the acidic or basic properties of that. Okay, So, which is the acidic COOH or carboxylic give the acidic property, NH2 or amine group will give the basic properties. Sir, our 20 amino acids are only differ by the R group. Absolutely correct. The 20 amino acids are different only by the variable group. Okay, all the other things will be same for all of them. Only variable group will be different. So it formed these many types of the amino acids. Okay. One second. I will take a screenshot because okay. So now it's good. I will move on. Okay. If you have or if you want to write it down, just write it down now only, because if I move to the next page, I can't come back to this page. But it will be in these this one notes, no problem. Okay. So I think I will move on. You can write it down in the notes also. Okay. Neutral ion we completed. If you come to the types of amino acids, we have different types here. When you see neutral amino acids, that means they have the neutral. These are not acidic, not basic. I think you know what's the basic and acidic, right? Based on the hydrogen ion acceptance or liberation, right? So neutrals are glycine, alanine, valine, leucine, and isoleucine. And acidic are aspartic acid, aspargine, glutamic, and glutamine. These get the acidic properties because of presence of more than one carboxyl group. Okay, more than one carboxyl groups will be there, or more than one acidic groups are there. Because of that, it getting the more acidic kind of the nature. And arginine and lysines are the basics. It have the more than one basic groups. Okay, and if you check here, this is important. I'm telling you. Okay, cysteine and methionine are the sulfur containing. S means sulfur. Okay, S means sulfur. Sulfur containing amino acids. But in this also, the methionine normally won't. I will discuss that later. Okay, no issue. I will discuss that in the protein. Just remember, the sulfur containing amino acids are cysteine and methionine only. This is important. Okay, I'm marking it. Okay. I'll tell you that. Alcoholics are serine and threonine. The aromatic are phenylalanine, tyrosine, tryptophan. This is important, which are the aromatic amino acids. And heterocyclic. Heterocyclic means having the cyclic with the nitrogen groups. Okay, they are histidine and proline. Okay, so these are the 20 amino acids name. You have to remember 20 amino acids name, but it's not urgent. Okay, so you can remember it now, or you can remember it when you are going for the 12th biology. There also in the fifth chapter, sixth chapter, it will come again, all the amino acids. Or you can learn when you are studying the biomolecules chapter in the chemistry. Okay, that time you have to study the structure also. Okay, but just try to remember the amino acids at least for some time, so it will help you to build in the 12th. Okay, R group could be methyl, ethyl, or higher number of CH2 group. Exactly, Shushmita. Okay, so some other things also join there, which can form a ring structure. We call it as the aromatic. S containing a variable group will be sulfur. S containing means variable group is not sulfur. The variable group will have the sulfur. Okay, so a variable group will have the sulfur. That's why we call it as the that particular one. Okay, don't think that that's only the sulfur. Okay, I will if I will write the system structure, then you can understand. I will write the system structure. You give me 1 second. Okay, so cysteine will be, these things are common. Okay, NH2 and COOH, and this side will be the H. Okay, here CH2 SH is there. Okay, this is the cysteine. Okay, this is the cysteine. Here you can see, right, the variable group is CH2SH. That's why it contains a sulfur, right? So that's important. Threonine, threonine is a drug. Like I didn't understand. Drug means no, it's not a drug. It's an amino acid. Maybe given as a supplement, I think. Okay, so we'll move on. There are like three kinds of amino acids are there. One are essential, non-essential, and conditionally essential. Okay, what's the meaning of then? What's the meaning of heterocyclic? It do have the ring, but ring contains the nitrogen atoms. Okay, so one thing, 1 second. I will come back to here. Heterocyclic. I will try to. It's a ring only, but the ring will contain nitrogen. Like if I write proline, I will try to write the proline then. CH2, CH2, and CH2, and CHCOOH, and N H. Okay. So this is the structure of the proline. So it form a ring structure, but it have a nitrogen. Okay. Aromatic will not have a nitrogen. So it have a nitrogen. So we call it as the heterocyclic. Okay. Whether it's necessary to remember the name of the amino acid, yes, it's necessary to remember the names of amino acid. It may be now or later. Okay. No. Cis isn't chiral. Cysteine isn't chiral. Everything except the I told you right, except the basic or glycine, all of them are chiral only. Okay. 12th chemistry, it's in full. Okay, full with structure also. Aroma means smell. This also have the smell. Yeah, exactly. This all 20 types of closed ring. No, 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 no. Who told you? Uh, only the aromatic will have the ring structure. Aromatic only will have the ring structure, and aliphatic will have the different kinds of the ring structure. All of them are others are this direct only. There is no ring structure. It's what we call it is. It's a direct structure. Okay. Why cysteine carbonates attached with two carbons? Cysteine carbon. No, cysteine carbon is attached to two carbon. This is the alpha carbon. This is the variable group. This is the variable group. This is the R group. Okay, this is the functional group. There are like three types. Essential amino acids means needed in diet. That means these not be formed, or these are not synthesized in our body. So it should be taken in the diet. That means in our food. Okay. Exactly. Okay. Correctly, Pika. Non-essential means our body can form. So no need from outside. Okay. No need from outside. So what is the meaning of this? Essential means our body can't form these amino acids. So we have to take these amino acids in the our diet. Okay. It may be in the plant, or maybe some other kind of the things, fruits, vegetables from there. Okay. But non-essential amino acids are can be produced in our body. That's why there is no need to take it from the outside. Okay. What are conditionally essential amino acids? Conditionally essential amino acids are the one which are needed when body in bad shape. Okay. What is the meaning of bad shape then? So when you are sick, okay, when you are sick, when you are having some trouble, or if you are going through some disease, okay, that time AA means amino acid. AA means amino acid. I told you in the starting, right? Exactly. So what is happening here? Sometimes when you are going through a disease, okay, that time bodies do not have the capacity to produce those kind of amino acids. That time these amino acids are essential to take it from the outside. Okay, so this that's why it's called as the conditionally essential. Not always, but only during when we are having through a rough time. That means body is having the some disease, or you are have bedridden to something on that kind of times. Okay, so essential not needed in essential needed in diet, non-essential not needed in diet, conditional essential only needed during the bad times or during the disease. Okay, bad shape means disease. It is formed in our body. Yes, non-essential will be formed in our body by taking different molecules. Okay, different molecules. Glycerin available in sanitizing or in hands, where we mentioned. Hi, this that is glycerine. Okay, this is glycine. Okay, two things are different. Glycerin is different. Glycerin will be different compound. Okay. Okay. So these are the things related to the amino acids. Okay. Mm, we'll move on. This is just simply representing these are essential. That means have to take on through the food, and these are non-essential. That means our body only can produce it. Okay, so this is a kind of eukaryotic cell. Okay, you can't eat the sanitizer. You should not, because sanitizer will be highly problematic. Either it may contain ethanol, or sometime it may contain some other components. It's harmful to our body, so you should not. Okay, sometimes it may added with the methanol also. Methanol is highly poisonous. Probably you heard it or not. In the initial days of corona, yeah, probably in Hyderabad, sorry, in the Andhra Pradesh. Okay, lot of people. What happened? Every this alcohol shops are closed. Right, they are not getting the this one alcohols readily, but they are getting the sanitizers. And somebody told that the sanitizer contain the alcohol. Okay, they thought that both of the alcohols are same, and they drank it. Okay, because of that, lot of people are get hospitalized. Some of them died also. Okay, because it causes serious problem. It will completely disturb our balance of the ionic and the water balance. Okay, it's highly dangerous, highly dangerous. Okay. Mm, no need now. No need to remember all the amino acid for now. Essential. It will be in the 12th class. Okay. Yeah. Methanol is highly poisonous. Okay. Methanol is highly poisonous. Ha, Nirodha. Mm, ha, you can say like that, Akshay. Difference in the composition. Normally, the compositions are different. What regular people will take, that alcohol, right? That will be contain 15 to 20% or 30% of the ethanol. Okay, but the sanitizer will contain more than 70%, and also it may contain other kinds of alcohols. Okay, not only ethanol, there may be some other kinds of alcohols also may be present. Okay, and there are some other chemicals also added for the most effectiveness. That's why you should not drink that. Those things are not same. Okay, methanol is poisonous to our body. Methanol will kill you. Okay, that's why you should not. Beer will contain very less kind of the alcohol. We will see that. Okay, we will study about all the different kinds of alcohol in the plant physiology. Don't take tension. Okay, I will tell you how many percentage will be there, how to produce it, and everything. Okay, okay. We will move on. We will move on to the questions then. Okay, the number of amino acids occur in cells are there. How many occur in cells? 20, 26, 200, and 170. I'm just launching the poll. I don't think anyone need the time. Right. Yeah. This is one of the dead easy question. I think module question it is. I think this question is in module. Okay, you guys. Last 10 seconds. I just muted myself for 2 seconds. Not 2 seconds, 30 seconds. Okay, I'm ending the poll then. 82% chosen option A, 11% B, 4% C, and 3% D. I'm stop sharing the results. And yes, as you guys chosen, most of you are chosen. And in YouTube also, everyone chosen option A only. The correct answer is option A. Okay, even though there are like several kinds of amino acids are present, the most important and protein forming amino acids are only 20 in number. Okay, so we'll move on to the next one, the components of DNA and RNA. Remember, we are not going to study about protein here because protein is a macromolecule, and I'm not going to discuss about lipid also because lipid also a kind of macromolecule. Okay, we will consider it in a macromolecule, even though the size is smaller. And we are again not going to study about DNA and RNA completely, because that's also macro only. Okay, we are only studying about the components of DNA and RNA. Okay. Uh, Amino acid will be present in more in your body only if it is contain more. Muscle cramps will happen. I'm not sure about that. Muscle cramps will happen because of the some other reasons. Okay, not because of the presence of amino acids. Amino acids are essential. If there is more than enough amino acids are there, then body will remove the amino acid in the urine. Okay, so what happens? I will just going here. Okay, so if you look at these things, and if anyone, any person, if you know, are going for the gym and everything, they will take a protein shake powder, right? If you check that, you can find several amino acids which are mentioned in here. Okay, it may be a cysteine, or it may be the this one arginine or tryptophan. Tryptophan is the one of the important, very important amino acids. Okay, why it's important? Because this helps in these several body formations. Okay, muscle formation. Creatinine, there is another one called creatinine. It will the precursor element. By dividing of the creatinine, other amino acids will be formed. Okay, so you can find all those things. But those people who are going to gym, they will only take one spoon and they will do the workout, right? Why they won't take, and they will, if you ask them like, can I take this powder, then they will say no. If you are going for workout, or if you are doing the exercise, then only you have to take, otherwise it is not working. Why? Because if you take more than enough amino acids, the amino acids will be removed from your body through the urine. Okay, it will be like never utilized. It's not like fat, or it's not like carbohydrate to store it somewhere. Amino acids normally taken how much it's needed only. If it is more than enough, then it will be removed in the urine. Okay. mm, exactly. So components of the DNA and RNA, exactly. So components, or you can simply call it as the, we are studying about monomer of the DNA and RNA. Okay, what is the monomer of the DNA and RNA? The monomer is the nucleotide. Okay, so we will study about the nucleotide, but before that, what is the composition of this nucleotide? This nucleotide, why fat is also not stored in some people's body? It will be stored, but not in that much of amount. It majorly based on our genes. Okay, our genes that is controlling all those structures, all those things. Okay, so nucleotide is contain sugar. Okay, and also a nitrogenous base. Ha, correct, Shushmita. And also a phosphate group. Okay, also a phosphate group. What is sugar then? The sugar which is present here is a pentose sugar. What is the meaning of pentose sugar? Can anybody tell me what is the meaning of pentose sugar? The sugar which is present in here is a pentose sugar. Okay, exactly. It will have the atom. Okay, atom. The pentose sugar normally present in this form. Okay, what I'm writing here, right? This form. So this will be the CH2OH. That means H. Here should be OH, and here's, sorry, below portion will be H, and here will be the H and OH, and H will be the OH. Okay. Pentagon shape, exactly. This particular sugar, we call it as the ribose sugar. Okay, the name of this sugar is the ribose sugar. If you go for the monosaccharide and aldosis and ketosis, there I mentioned the ribose sugar. Okay, it's a sugar. But sometimes this pentose also present in another one form. Okay, what is that form? That form will be little bit different from this one. What, how it will be different? The only difference will be, once again, CH2OH, H, HOH, and H and H. What's the difference then? What's the difference? The only difference is a lack of oxygen in this particular point, where I have to tell this is the first carbon atom, second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom. That means there is a lack of oxygen in this fifth carbon atom. This particular sugar is called deoxyribose. Okay, deoxyribose. Deoxyribose ribose means what? D means less, okay, or removed. Oxy means oxygen, okay. Oxygen is removed from the ribose sugar. That's what we call it as the deoxyribose sugar. In which position? It is in the position of second position, or in the second carbon atom. Exactly. You have to remember this second carbon atom. You have to remember, okay. So this is relating to the sugar. What about phosphate group? Phosphate group will be normally present in H3PO4. Okay, H3PO4 is the phosphate group. Which oxygen? The oxygen which is present in this second carbon, which is present in this second carbon. 1, 2, 3, 4, 5. Remember, second carbon atom. Here, it's removed here, right? The carbon present in the second carbon. Okay. Nitrogenous base we will study. Third one is the phosphate group is the H3PO4. Okay, so that's what. So we will move on to the next one, nitrogenous base. Okay. So what is this nitrogenous bases then? Okay, what are these nitrogenous bases? These nitrogenous bases are actually the nitrogen containing groups. Okay, nitrogen containing groups. It's again divided into two different types based on its structures. One will be the purines and another one will be the pyrimidines. Okay, the purines is the structure which having the two rings. Okay, it will be having two structure rings. Okay, previous slide. Just a second. Don't concentrate about this particular diagram. Don't concentrate about this particular diagram. Okay, they added uh, to you people to know the. Okay, I explain later. Okay, yeah, I will move on. So this will having the adenine and guanine, two kinds of the purines are present. Purines will have the two ring structures. Okay, it will be having two ring structures. The structures are not at all important. Remember, you have to remember only one thing. Nitrogenous bases will be divided into two types, and the first one will be the purines. Purine will be having two ring structure, and these are adenine and guanine. Okay, and pyrimidines are having the single ring structure. It will be having a single ring structure. These are three types are there. One is the cytosine, thymine, and uracil. First word will be taken as the common thing. Okay. Which are the nitrogenous bases then? Nitrogenous bases will be adenine, guanine, cytosine, thymine, and uracil. And in that adenine, guanine are purines. Cytosine, thymine, and uracil are the pyrimidines. Okay. In this, where what will contain? Okay, that is we will see. In DNA or deoxyribonucleic acid, the nitrogenous bases which are present are adenine, guanine, and thymine and cytosine. But if you take an example of the RNA will contain only the adenine, guanine, uracil, and cytosine. That means what is the difference? The thymine will be present in the thymine will be present in where it is present in the DNA, and the uracil will be present in the RNA. This is the only replacement things. Okay, not the any others are replaced. Everything is same only. Only this thing is replaced. What is the reason behind this? The structure is only slightly different. That means uracil have a H function, H group in this particular carbon atom. Okay, so that may be one, two, three, four, right? But thymine contain a methyl group. Okay, because of this methyl group, thymine is more stable than the uracil. I mentioned that in the initial class only, right? The DNA is more stable than the RNA. What is the reason for that? The methyl group which is present in the that particular structure give rise to the thymine. The thymine is more stable than the uracil. Okay, that's what gives the stability or more stability to the DNA molecule. Okay. Genuine waste. I didn't. Gone in waste. No, 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 no. Ha. No. That's only waste in the these things. What is that? I forgot the insect name. So only in not insect arachnida members. Only in the spiders. Okay, only in the spiders, not in others. Why thymine is not present in the RNA? RNA first formed actually. Okay, RNA is the one which is formed in the first phase, but later, due to some reasons, it's changed to the CH3. We gave the new name for this one. Okay, when it's changed to CH3, we call the molecules in a different name. That is the in the it's more stable. It will become more stable, and we call it as the thymine. It's just present in there. Okay, spider. Yeah, I got it. Okay, we'll move on then. So when this nitrogenous base and sugar will form, then we call it as the nucleoside. Remember, when the nitrogenous base and sugar will join, then we call this as the nucleoside. Okay, so how it will form then? This sugar, which is present in here, will form a bond. Normally, OH will be present, right? This OH will form a bond with this particular nitrogenous compound with a bond. Which bond it is? With a N-glycosidic bond. Okay, with a N-glycosidic bond. Why we call it as the N-glycosidic bond? Because the glycosidic bond will happening with a nitrogen molecule. Okay, a nitrogen molecule which is present in that nitrogenous space. That's why we call it as the N-glycosidic bond. Remember, the bond happening between this nitrogenous base and sugar is the N-glycosidic bond. Okay, so how we change the name, or how we call it? Okay, when adenine bonds with a sugar. Okay, so if it is remember, if it is with the RNA or if the ribose sugar. Okay, then we call it as the adenosine. Guanine with sugar, guanosine. Cytosine with sugar, cytidine. Thymine with sugar, thymidine. Uracil with sugar, uridine. Okay, but how you have to call it? If it is bond with like adenine, take an example, bonded with deoxyribose sugar. Deoxyribose sugar. Okay, ribose sugar. Then how can you call it? Then we call it as deoxyribo, deoxyribo adenosine. So just an example, you can make it for all the other things, right? So how it will be different? When nitrogenous base and sugar will join, then we call it as nucleoside. Remember, nucleoside. So nucleoside will be adenosine, guanosine, cytidine, thymidine, uridine. But if instead of sugar or ribose sugar, if it is joined with the deoxyribose sugar, then we call it as the deoxyribosine, deoxyribotymidine, that much only. Uridine normally not present. Okay, exactly, Shushmita. But when that nitrogenous base and sugar, or you can simply say nucleoside, nucleoside will bond with a phosphate group, then we call them as the nucleotide. Then we call them as the nucleotide. Remember, where is forming the bond? This fifth carbon atom is bonding the a bond with the phosphate group. This particular bond is called ester bond. Ester bond. Exactly, esterification or ester bond. Here you can find the N-glycosidic bond. N-glycosidic bond. Okay, remember, you should also remember which carbon atom is forming which bond with the other things. The first carbon atom is forming bond with the adenine. Okay, second is empty, third is empty, fourth is empty. Okay, again the fifth carbon atom is doing bond with the phosphate group forming the ester bond. Okay, so here again you have to think, when the adenosine or the adenine plus sugar, or I can also write adenosine, right, nucleoside only, joined with a phosphate, we call it as the adenylic acid. Guanine sugar, phosphate, guanylic acid, and cytidilic acid, thymidilic acid, uridylic acid. Okay, what happens if the same thing happens with the deoxyribose, deoxyribose sugar? So I will take an example of adenosine, adenine. Okay, adenine plus deoxyribose plus PO4 minus that one. Then it will called deoxyribo adenylate acid. Adenylate acid. So you have to add the deoxyribo. Okay, same thing. Deoxyribonucleic acid, deoxyribocytidilic acid, deoxyribothymidilic acid. This is how you have to state. So remember, when adenine and sugar, it will be the nucleoside, and when phosphate is added to the nucleoside, it will be nucleotide. This is the important thing. These are the building blocks of the DNA RNA. By joining different types of nucleotides, it makes the form. So we call it as the DNA. I have mentioned that in the word also. Okay, the component of DNA is nucleotide. I'll mention it there only. Okay, no problem. Nucleotides are the, that's why we call it as nucleotides are the monomers of DNA Hello. So I'm disconnected for 1 second. Okay, no issue. I'm repeating once again. Uh, exactly. So nucleotides are the monomers of DNA or RNA. In another way, I can call the nucleic acid. Nucleic acid may be DNA or RNA. Okay, simpler term. Not audible. Now also. Wiki, okay, okay. Ha, okay. This much only. Okay, this much only. If you have any doubt, just put me. One question will came. DNA is different than RNA in. They're asking DNA is different in RNA, in amino acid, in phosphate group, in sugar, or in the nitrogenous base. Okay, so we will discuss. We will discuss this in the next class. Okay. So we'll discuss this question in the next class. So I have to repeat. Nucleotides, I'm telling, these are the monomers of DNA or RNA. That means nucleotides will combine and they will form the that particular type of the either DNA or RNA. Okay. So I will discuss that question later. Okay, no problem. So I'm just launch the teacher NPS. So answer the teacher NPS. After the NPS, you can leave your class, or if you have any doubt, you can answer. Don't take tension about the answer. Okay, we'll discuss the question tomorrow because some mistake is there in that question. I just saw it now. Okay, answer we will discuss tomorrow. I will ask the same question tomorrow morning. Tomorrow first question. Okay. Thank you. If you didn't understand anything, just put a message. So anyway, tomorrow class we will repeating that. Remember, this is very important chapter. Even though you're going for the medical, the first year you will study about biochemistry only, and you will starting from here only. Okay. So for your 12th class, for your 11th class, to understand the molecular and genetics, this chapter is very important. Okay, very important. So if you have any doubt, you can ask. Okay. YouTube guys, any doubts or anything? Okay. If you don't have the doubts, then I will close the session. Sugar, which one? Which part, Sanjana? Just tell me which part in the sugar. Yeah, I will repeat it. Okay. So nucleoside means nitrogenous base and sugar only. Okay. It's like a bracket between these two. Then we call it as the nucleoside. But for the nucleoside, if you add the phosphate, then it will become the nucleotide. Okay. So, really. Okay. So nucleotides are made up of nitrogenous base, sugar, and the phosphate. So when you add just a nitrogenous base to sugar, that means adenosine or guanosine. what we saw in the last slide. These are the nucleosides. What happens if I add another phosphate group to this fifth carbon atom? Okay, and this carbon will form ester bond with the phosphate group, and it will form a nucleotide. So it's a PO4, right? That means it's an acid function group. So it will become adenylate acid, guanylate acid, cyclidylic acid, thymidyllic acid, or uridylic acid. Okay. Mm, this ring structure is sugar only. Okay. I wrote 1, 2, 3, 4, right. Add an here nitrogen space. This is sugar. This is sugar. Monomers. Remember, when this nucleotide join one to one, I will come to the first slide. Okay. Yeah, I will explain that also. So when this nucleotide join one to one, this is a long chain. That long chain only called as DNA. That's why we call nucleotide as the monomer of DNA or RNA. Monomer of DNA or RNA. Okay. If you observe this particular structure only, if you observe this particular structure, here every these bonds are actually one nucleotide. One nucleotide. Okay. Regarding ribose and deoxyribose sugar, the ribose sugar is structure is like this. It's a pentose sugar, okay, having OH and H everywhere. But what happens in the second carbon atom? One oxygen is getting removed. Okay, this particular oxygen is getting removed. So when it is getting removed, then it will lack with one oxygen. That's why we call it as the deoxy, one oxygen less kind of the ribose. It's still a ribose sugar only, but the only difference is it lacks one oxygen atom. Okay, so that's why we call it as the deoxyribose. Okay. For no, Akshay. So what we are studying in nucleotide, right? It's just a ester bond or phosphoester bond. It's not the phosphodiester bond. Okay, we will see the phosphodiester bond in the later when the DNA. Okay, there I will explain that. I'm not sure about that. Why ribose is the name? Why we gave the name ribose only? I'm not sure about the name. Probably it may have some etymology. Try to find it. We will also get to know. Normally compounds name are not. I'm also not interested. Okay, because I have to search all those things. But it's some other names like scientific names. Then you can go easily. Someone asked about the this one's right. Sugar, right? Which in sugar, which part I didn't understand? Which part I have to repeat one more time? Can you please tell me so I can repeat it one more time? You have to. You also have to, Chirant.